Okay, so direct variation is a thing where you've got two variables, usually x and y, and direct variation implies that one is directly influencing the other. So they're varies, because they're variables. So in direct variation, as one variable goes up, it forces the other one up. Okay, so the most basic example is y equals kx. So these ones are just like straight lines. They're just a direct proportional type of relationship where k is just some number, and you'll see as we go on, it's called the constant of proportionality, or some version of that, and it tells you how x is, what happens to x to change y. Mm-hmm. So, but they're always going up. So, if for instance the constant of proportionality was 10, then we would get y equals 10x, and if x was 2, then y would be 20, which is 10 times 2. So, and then if x was 3, y would be 30. So as x is going up, so is y.
Okay.
So there are 4 types of direct variation. So we have y is directly proportional to x. Okay, so that just tells us that nothing fancy is happening. There's just some sort of constant being multiplied by x to give that. Mm-hmm. So they also have y is directly proportional to the square of x. Mm-hmm. So what that tells us is that x is being squared, and there is some proportional constant again. So we have y equals kx squared. Okay, the third one, that all starts off the same, and the cube of x. So that tells us that it's going to be y and x cubed, and a constant again. So this constant is always here. Mm-hmm. And then the last one is the proportional to the square root of x. So we have y and a square root x, and then we have our constant coming back again. So they're the 4 types. The question will have that keyword in it. It will have square root, it will have cube, it will have square root. If it doesn't have any of them, it just has proportional. It's just y equals k of x. Yeah. So in each of these questions, they'll give you 2 variables. And the most basic ones will just be x and y, and I'll say those fancy words, and you'll have to pick which equation it is. But sometimes they'll change the variables up, and they'll have m's and r's and d's and s's, t's, all sorts of different letters. Mm. So it's all about picking out what variable you need to be using. So if they say something like the mass of a ball, m, varies directly with the cube of its radius. So it says the mass varies inversely with the cube of its radius. So when it talks about it varies inversely with the cube, it means the varying is happening with the cube. So if the radius is varying with the cube, like if the radius is being cubed, mm-hmm. It gets that thing, and the mass is the other thing. So it says that this equation here says the mass is varying directly with the cube of its radius. So we have to set up the equation that way, and they won't give you the equation, they'll just tell you a sentence and you've got to pick it out. Yeah. So if it has the word cube in it, obviously it's going to be the cubed type. Yeah. Okay. And from there, what they will do is they will give you some information. So if they say, for instance, a ball has a mass of 324 grams and its radius is 6 centimetres, we can do a little bit more with this equation. Mm-hmm. So if they tell us that the mass is 324, we can replace m with 324, and the radius is 6. We start creating this equation. So 324 equals k times now 6 cubed is 216, I think. And so then to solve this, to find out what this k actually is, we're going to, what are we going to do?
216 over 324.
Other way. So I want to get rid of this, so I have to get rid of that 216, which means I have to stick that over there. So that gets rid of the 216, which just makes it 1. And then we simplify 324 over 216. So we simplify that, we get k as 1.5, which means that the final equation, so we can now put that 1.5 in the spot of k. So that there is a finalised equation. I've got my constant. Okay, it's no longer a k, it's a 1.5, and I can work out any question with that now.
Okay.
So I can be given a radius and I can work out its mass, or I can be given a mass and I can work out its radius.
Okay.
Alright, so let's do that. Let's say if m equals 1.5 r cubed, let's say what's the mass if the radius is 5. So all we have to do
Times them.
is put the 5 in the r spot. So 1.5 times 5 cubed. And what do we get? 187.5 grams. Okay, and then, alternatively, we can say what is the radius if the ball is 1,000 grams. So we put it back into that original equation. So the original equation, 1.5 r cubed, the mass is now 1,000, equals 1.5 r cubed. So how do I get rid of the 1.5?
You 1,000 over 1.5.
Yeah, so over 1.5, over 1.5, that cancels that away, and 1,000 divided by 1.5 is 666.6 repeater. Okay, and if I want to work out what r is, what do I need to do to get rid of the cubed?
Did you divide it by 3?
No.
Or
So
you cube root.
Cube root it. So what is the cube root of that?
Good question.
And we get, let's just go up here, 8.74 centimetres. Okay, so you can, like, all of the equations work the same. You get some sort of connection between two numbers, work out what that is, and that's what we call this constant of variation. And we use that constant of variation to set up the final equation, which we then use to solve, if we want one variable or if we want the other variable. Okay, the other type is inverse variation. Now in this one we still have two variables, we have x and y, but in this case as one variable goes up, the other one comes down. So what these ones look like, the words are similar, but they'll have this all important word inverse. So if you see inverse, or if you see indirectly, or something, the word in, so it's meaning opposite. So these ones, most of them look like this, but they all function the same way. Like you're going to get an x number and a y number, and you're going to work out what k is, and then it's exactly the same process, just with different formula.
Okay.
Now they will say that, say the cost of something is inversely proportional to the number of people attending, and they won't have squared, or like most of them are this type. Occasionally you'll get, y equals k over x squared and things like that, but again, you're looking for that keyword squared or cubed or square root, but most of them that you come across will just be this basic type, and we do exactly the same thing. All right, so if we look at an example, let's say the cost C to hire a reception centre is inversely proportional to the number of people attending. So it's got that word inversely, so it means it's K over, and it's just inversely proportional, so that just means it's just a constant.
Is it always K over? It's
always K over with the inverse. Okay, and then it says if there were 50 people, then the cost is $36. So if we've got 50 people, then the cost is $36. So we can work out K from this. So if C is 36 and N is 50, all right, to solve this, what do we have to do?
Times it by 50.
Times it by 50. So that works out at 1800 equals K. So if we finalise our formula, we get something that looks like that. Okay, so then we can use this information, we can work out how much it costs if there's 100 people, how much, if we want to make it $10 a person, how many people we've got to invite, that kind of thing. Now in this question, what does 1800 represent, do you think?
I don't know.
So it was, we were hiring a reception venue.
The number of people?
No, N was the number of people.
Right.
And C is the cost per person. This is actually how much the whole room costs. All right, so if they want to hire a hall, say, to have a function, it's going to cost them $1,800. If we had 100 people, then each person's going to pay their own way in, and it's going to cost them $18 each to make up that full amount. Okay, and that's just what's happening in this question. It's not, it might not always be a cost thing, and different things.